habitable zone is not fixed. It moves depending on the star, the planet, and even the atmosphere. The habitable zone is a range of distances from a star where a planet with the right atmosphere can keep liquid water on its surface, which is an essential ingredient for our kind of life. But this range is not a hard line, and it shifts depending on the star type, planetary properties, and climate feedbacks. Move too close to the star and you hit the inner edge. Here, increasing stellar flux triggers stronger greenhouse warming. At the moist greenhouse limit, the atmosphere becomes rich with water vapor, hydrogen escapes into space, and oceans slowly evaporate away. Go even closer and you cross the runaway greenhouse limit, and oceans boil away completely because the atmosphere can't radiate enough heat to balance the incoming energy. On the flip side, move too far out and you hit the outer edge. Here you need relatively higher carbon dioxide to keep the surface warmer, but carbon dioxide is a double-edged sword. Too much increases really scattering, reflecting more sunlight, and CO2 clouds can form, both of which cool the planet. The maximum greenhouse limit defines the cold outer boundary of the habitable zone. Beyond this, even massive carbon dioxide buildup won't prevent the surface water from freezing. The habitable zone also moves outward as a star ages and gets brighter. For cooler stars like M dwarfs, the habitable zone is closer in, but then high UV and stellar flares can erode the atmosphere. On the planetary side, mass, rotation rate, tilt can also affect the habitable zone boundary. In the end, this is a waltz between the star, a planet, and its atmosphere, creating the right climate. Change one thing and the whole zone moves because